Okay, boys and girls, this is Mr. Newman. Today we are going to practice dividing with area models. So the first thing I'm going to do is I'm going to change these directions a little bit. The directions say solve using the standard algorithm of division. I haven't taught you the standard algorithm of division yet. I'm going to, just not yet. I really want you to know these area models first. And then we can practice the standard algorithm probably next week, probably Monday. All right, so I'm going to change these directions a little bit. So I'm going to cross out the word standard algorithm, solve using, and we're going to say area models. Area models. This is how I want you to solve these today. I want you learning this method, okay? And you guys are familiar with area models because of multiplication, but we're going to use area models the same way. We're just going to do them a little backwards. All right, I'm going to zoom in a little bit here. And we're going to do number one together. So if you want to go ahead and copy this down with me in your math notebook, that would be awesome. 46 divided by 2. Now, I realize 46 divided by 2, most of you could probably do that mentally. You don't need to show any work. But for the purposes of learning these area models, I would like to show how we can maybe use an area model to solve this. So we're going to start off pretty easy. Then it's definitely going to get a little tougher. Okay? So the first thing I like to do is always estimate these problems. Just gives me an idea of what my answer should be close to. 46 divided by 2. I'm just going to use a friendly number here and say I'm going to change this to 50 divided by 2. 50 is very close to 46. I can easily cut 50 in half. So the estimation that I'm going to be looking at here is 25. Half of 50 is 25. So this is my estimation. Okay? All right. So I'm going to go ahead and draw an area model. I'm going to draw just a simple box here. And I'm going to put 50 inside. Now 50 in this problem is called your dividend. This is your big number. And then the divisor in this problem is 2. The divisor is 2. That's how many times we're dividing it up. We're looking for the quotient. That's going to be this number right here. In an area, this question mark, the part we don't know, times 2 has to be, why did I write 50? Yeah. Not 50. We're not using the estimation. Sorry, it's 46. My bad. 46. And then 2 is going to go out here as this is my length, and the width I do not know. I do not know my width, but I do know the area. It's 46. So something times 2 has to be 46. Now I'm going to do something a little easier to help me figure this out. I'm going to do something a little easier. I'm actually going to break this number up into 2 smaller parts that is just easier to work with. And I'll show you what I mean by that. I'm going to come down here and draw another area model. Just very simple area model. And I'm going to put 46 in here again, but I'm just going to break it up into 2 easy parts that I know 2 can go into evenly. I'm still dividing by 2. Instead of writing 46, I'm actually going to break this up into 40 plus 6. 40 and 6. So it's still 46 inside this box. It's still the same thing as this. It's just broken up into 2 smaller parts. Why did I pick 40 and 6? Because I know easily 2 times 20 is 40, and 2 times 3 is 6. And if you look right here, this is my quotient right here. 20 and 3, 20 plus 3 is 23. That is the quotient. That's my answer. That is my answer. So I'm just going to come down here and rewrite this problem again. 46 divided by 2. And then if I look here at the width of my model, that was my quotient. That's my answer. You're going to hear me say the word quotient a lot. So it is 23. And I'm just going to verify that with my estimation, and very reasonable, very reasonable. So here is my answer, 23. That's my quotient. Now I realize you probably could do that in your head. You could probably split 46 in half very easily and get 23, but this is the area model that I want you to get used to solving. Okay, and these will get a little harder. Let's do number 2. Let's go and do number 2. Now you can always pause this video, go back, look at this problem again, recopy it. I have to get rid of this to go do this problem. So this is going to leave. This is going to leave, and we're going to do number 2. We're going to do number 2. So now we have 96 divided by 3. I'm going to go and estimate this real quick. I'm going to use the friendly number of 90 divided by 3 because that's pretty easy to do. You should be able to do that mentally. 90 divided by 3. And that should be 30. And always it's a good idea to check this. Just work backwards with multiplication. 30 times 3 is 90. So 90 divided by 3 is 30. So here's my estimation, 30. I'm going to draw an area model and just show you what this is going to look like. My area is going to be 96, and my length is going to be 3. I'm looking for this width. I'm looking for the width here. Remember, because length times width equals area. All right, I'm not going to use 96 to solve this, though. I'm going to break this up into something a little easier to work with. I'm just going to redraw this box here. And how could I break up 96? What is some good choices? Mo, you got a good choice?
You could do 90 and 6.
Oh, I like that. 90 and 6. 90 here. I'm just going to cut that there and put 6 here. 90 plus 6 is 96. Still the same thing. What times 3 gives me 90? Well, that's 30 at the top there. And then what times 3 gives me 6? That would be 2. And you can see, here's my quotient right here. 30 plus 2 equals 32. So my answer to this problem, 96 divided by 3. If I look right here at my width, it's 32. 32. That's my answer, and it's very reasonable. Okay? You guys getting the hang of this? All right, let's do another one.
It's easy.
It does get a little hard now, but keep in mind, we're just using 2-digit numbers. When we get into 3-digit numbers, it will get a little tricky, okay? All right, let's do number 3. This one we're going to do a little differently, and I'll show you why in just a second. Friendly number here, 85, 85, 85. I'm going to use 100. The reason I'm going to use 100, and I know it's a little bit further away than what we like to do, but it's just easy to divide 100 by 5. 100 divided by 5 is 20. So that's a reasonable estimation. Very reasonable, 20. So my answer should be somewhere around 20. 100 divided by 5. This time I'm going to draw my area model differently. I'm actually going to use this shape of a rectangle, which is fine. You can still do this. I'm going to put 5 up here as my width. I don't know my length, but I do know my area, which is 85. You could definitely get away with doing your area model like this. Some of you may like this area model a little differently, or a little betterly. 85 divided by 5 equals a number. All right, let's figure out how to break this number up. So I'm just going to redraw this area model. And remember, what I put inside has to be equal to 85. I'm dividing by 5. What is a good way to break this up? What is a good way to break this up? Well, let's just do 50. Let's do 50. If I do 8, I'm just going to come up here and show you 85 minus 50. I'm left with 35. So let's do 50 and 35. Those are both multiples of 5, and I can easily do 50 divided by 5 and 35 divided by 5. 50 divided by 5 would be 10, and 35 divided by 5 would be 7. So 10 plus 7 is 17. That is my quotient. So 85 divided by 5 equals 17. That is my answer, 17. And you can always check this. You can always check this by doing 17 times 5, and you should get 85. I think the directions say you are supposed to check these. I know I haven't been doing that, but I'm trying to make this video a little shorter. You can always check these. Always check these. It's a great idea. And if you check it and get the right answer, you know you solved it correctly. All right? All right, I'm going to skip number 4. I'm going to go ahead and skip this one just to save a little bit of time. I want to get to one that has a remainder, that has a leftover, and show you what's going to happen when you have a remainder. So I'm going to skip number 4 because number 4 will not have a remainder, but I believe number 5 will. So let's see if it will. Let's go ahead and go down to number 5. All right, number 5, 53 divided by 3. Let's do this one, 53 divided by 3. What is a good estimation for this? Remember, I like to use friendly numbers. I don't really know my multiples of 3 past 3 times 12, that's 36, but I could change this to 60 divided by 3. That's very easy to work with. 60 is close enough to 53. You could definitely do that. And 60 divided by 3 is just 20. Is 20. That is a good estimation. Let's check this. 20 times 3 is 60, so good. All right, I'm going to do an area model. Doesn't really matter how you draw your rectangle. I'm going to stick with this kind of vertical rectangle here. We have 53. That is my area. And then I'm going to do my width is 3. I'm looking for this length. Okay, remember, length times width equals area. So this is my dividend. This is my divisor. I'm looking for the quotient, the answer. All right. Okay, let's figure out how to break this number up. I'm going to go ahead and redraw another area model just to make this a little easier to solve. So first number I'm going to do is probably 30. 30 is very easy to work with. What will be next? Well, if I do 53 minus 30, how many do I have left over? Well, I have 23. Notice I'm not going to put 23 here. I'm not going to do this because nothing times 3 gives me 23. So that is not a good number to use. That's not a good number to use. So I am going to I'm not going to use this. I'm not going to use 23. So I got to figure out what to use here. If I do I'm just going to come up here and figure out, okay, what is the biggest multiple I can put that is still going to be a multiple of 3 but not go over 23? Well, let's see, 6, well, actually, we're not using 6, sorry. Oops, let me go back to that. Didn't mean to do that. There we go. Let's do just some multiples of, 3. Let's do some, look, I have a lot of hands raised, so it looks like some of you guys know this. Let's do 3 times 5 is 15. I can get closer. Let's do 3 times 6 is 18. I can still get closer. 3 times 7 is 21. And 3 times 8 equals 24. That's too much. So it looks like this is the perfect number. So I'm going to put 21 here. 21. Now, if I take away 21 from 23, I get 2 left over. And I know 2 is not a multiple of 3, so I'm just going to put this 2, kind of a little baby box down here at the end. And I'll show you why I did that in just a second. Let's figure out what these numbers are for my quotient. So 30 divided by 3 is 10. 21 divided by 3 is 7. And notice 3 cannot go into 2. It's too small. So my answer for this problem is going to be 17 with 2 left over. So I'm just going to say R2, which means remainder 2. 3 cannot fit into this number. So this is your remainder. So 53 divided by 3 equals 17 remainder 2, and that's still very reasonable to that explanation. So when you solve some of these in 4th grade, sometimes they don't work out nice and pretty, and it's just going to be the leftover amount. This is leftover. That's going to happen a lot. Okay? Does that make sense? Do you see how I did this problem? So when you end up with a number like 23 and you realize, hey, that's not a multiple of 3, you've got to figure out the closest multiple without going over, and the leftover is just going to be the little box at the bottom that your divisor can't go into evenly. Let's do one more together. One more, then you're going to practice some on your own. All right, 95 divided by 4. 95 divided by 4. Let's go ahead, and I'm just going to estimate this. Anybody know a friendly number? Say it out loud. 100. Very good. 100 divided by 4, and you should know that just equals 25. That's like $1 cut into 4 is quarters, 25 cents. So $1 cut into 4 is 25 cents. That's how I remember that. 25 times 4. 4 quarters is $1. All right, so 25 is my estimation. I'm going to draw an area model. I'm going to go back to the horizontal area model. Some of you guys may like this better. It doesn't matter. 95 divided by 4, and this time I'm looking for the width. I have my length, I have my area, I'm looking for the width. Remember, length times width is area. All right, let's figure out a better way to cut this number up. Let's see here. What is a good way to cut this number up? Who knows a good first number to use? Who wants, Jay Francis? Well, see, the problem is 4 doesn't go into 90 evenly, so I don't want to use 90 because 90 is not a multiple of 4. So that's why I don't want to use 90. But we can use a number close to 90. That would definitely work. Anybody know a good number close to 90 that you know works? What? 75? No, 4 doesn't go into 75. 75 is not a multiple of 4. What do you got? 80. Yeah, let's do 80. So 80, that's a great number. 80, and then that means, let's see what's going to be left over. Let's do 95 minus 80, and that's going to be 15. Now, 15 is not a multiple of 4. You should know that. So we got to get a number that's close to this, a number that's close to 15. Let's run through some multiples of 4. 4 times 3 is 12. That's pretty close. 4 times 4 is 16. That's too big. That's out. It's got to be 12. So we're going to use 12 in there. So let's go ahead and subtract 12 from 15. Actually, no, we're going to subtract 12 from 80. Sorry. So we got 15 minus 12, and then we got 3 left over. So that 3 is going to be this little box right there. That's the part that 4 can't go into. This is going to be your remainder. All right, so you could see, let's just check this. 80 plus 12 is 92, plus 3 is 95. So this still represents 95. It still represents the same thing as it represents here. We just broke it down into easy numbers that 4 can go into and then a number 4 cannot go into. So 4 times 20 is 80, 4 times 3 is 12, and 4 times nothing is 3. So what is my answer to this? 23 remainder 2. You got it. So 95 divided by 4 equals 23. And you can even do this. You can say left over. You can say left over if you don't like the word remainder. 23 left over 3. 23. 23 with 3 left over. Okay? And that is your answer. Is that reasonable? Is that close enough to 25? Definitely. Definitely. All right. So there is 5 practice problems. If you look on Canvas underneath this video, you will see 6 problems that I want you to do on your own. Just do them on notebook paper, or even better, do them on graph paper. Take a picture, submit it for credit. You guys have a great day, and see you, bye!